Okay, so as previously stated, the first thing that we would do each day is come to our e-class page and see if anybody's stuck on anything. I'm surprised nobody has come to see me yet about taking a screenshot on their device. So I'm assuming we're all screenshot experts.
No. Okay, I have a problem. I just downloaded it.
Hey, we got some slides.
That's me. I accidentally made a new one. I took two screens. Like, you know how it says which one assignment? I actually made a new one called math, but I put the rest of my two screenshots in week one. That.
That does not mean that you have to work until Sunday at 11:59. That will be the last minute that you have to work. Get some before that.
I do have to work. Yes.
Sure. Yeah. Why wouldn't you have to?
No, never mind.
Can we get started?
Yes.
Okay, so here we want to, it looks like we're adding mixed numbers. If you watched my instructional video where I went through the steps, you may have been taught how to do this differently. I really don't like it, and I can't. There's some things where, like in math, you can do more than one way, and I really find it's a matter of preference. But I cannot see the benefit in leaving the numbers mixed. So I'm pretty firm on this one. I would strongly advise you to, first step is to convert to an improper fraction. So what numbers are we going to keep here?
We're going to keep 6.
Okay, fine, good enough. Which are the denominators, which are 6 and 4. Now, I know you wouldn't have to show me any work for how you get the new numerator, but I would hope that you know that we're going to multiply the denominator times the whole number and then add the numerator. So 8 times 6 is 48 plus 1 is 49. 4 times 4 is 16 plus 3 is 19. Okay. Now comes the key step for adding and subtracting. I would even argue, this is more of an opinion, but I would argue that this is why students tend to struggle, I feel, more with adding and subtracting fractions than they do with multiplying and dividing. Because this step is a requirement when you're adding and subtracting, but not when you multiply or divide, and that's that the denominators need to be the same. I need to have a least common denominator. Least common denominator, if you looked at the notes and you looked at my videos, it's the same thing as saying least common multiple. So what we're saying is that if we were to count by sixes, so 6, 12, 18, 24, so on and so forth, those are called multiples. 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5. And count simultaneously by 4s, so 4, 8, 12, 16, 20, ... ellipses. You will, depending on how far you go, you may find several common multiples. But in this case, we want the least common multiple. So what's the smallest number that both lists have in common? 12. So magically, we're going to come back to our problem here. We're going to write that least common multiple in the denominator. Hence the name least common denominator. Okay, but now we have to do some investigations. We have to see, look, this first fraction turns into this one. This fraction became this one. So we have to see first if they changed, and if they changed, how they changed. Now it's least common multiple, so if it changed via multiplication. Who you texted? It's amazing what you see from up here. You see it all. So just put it away. Multiplication. 6 times what is 12? 2. 12 is the second multiple of 6. So whatever you do to the bottom, you gotta do to the top. So what is 49 times 2? It should be 98. 4 times what gives you 12? 3. So whatever you do to the bottom, you gotta do to the top. 19 times 3, is that 57? It's 57. Did I know? It's mental math, but you can double check if you want. 19 times 3 should be 57. Okay. Now we're ready to add. Now that we have a common denominator, we keep the common denominator of 12. We can go ahead and add, but we only add the numerators. You throw in a monkey wrench for multiplication, because now when multiplication comes in, well, wait, but now I'm supposed to multiply the numerator and the denominator? Yeah, the rules are different. Multiplying has one set of rules, but when we add or subtract, we only do it to the numerator. So there's going to be 155 over 12. I prefer improper fractions. I believe Khan allows you to enter your answers improper. You can leave them improper. I don't have the ability to enter. This is a picture, so I can't enter this in. But what they will mark you wrong is if you don't, if you're able to simplify but you don't. Okay, so and just for the record, like there's only really one type. I might have asked you this before. I know I did it with one class. I don't know if it was you guys or not. There's only one type of problem where it really would require you to go back to mix. What types of problems does it make more sense to take an improper fraction and go back to a mixed number? You want a clue? It starts with M and ends with measurement. Measurements, yeah. If you have and those tend to be word problems. Those tend to be word problems. So if you have something that's being measured in inches, feet, if I were to say, yeah, you know, I'm really thirsty, I'm gonna go drink 155 over 12 cups of water. In this case, the unit being cups, like that wouldn't make sense. But if I were to go back to a mixed number, maybe that would make sense. But I'm gonna leave it improper. But I gotta see, can I reduce? How many numbers do we presently see on the board? How many numbers do we presently see on the board right now in the set that we left off? There's two numbers there. There's 155 and 12. Okay. Now instead of a least common multiple, we go to the opposite, which is known as a greatest common factor. Instead of multiplying, now we're going to divide. Is there one common number that can be divided into both of these? And if there's more than one, now what's the greatest number? Well, since 155 is odd, I know that any even factor of 12 is not going to work. 2 is not going to work. 4 is not going to work. 6 is not going to work. 12 is not going to work. So really, there's only one number that it could maybe be. Yeah, 3, maybe. So try on the calculator. Do 155 divided by 3. If you get a whole number, then it works. If not, then you don't. I don't believe it should work.
Yeah.
It doesn't work. So what I would do if it were me, and unless you tell me otherwise, that like it didn't work, but I've worked with Khan Academy for a while, so I'm pretty sure that they'll accept it. What I would enter here is 155 slash 12. Yes, ma'am. Ruth, right? That's a good question. So she says, so you can't change it back to mixed. I never said you can't, and I believe that they will accept both. I just don't see the need for it. I believe they will accept both. Like they've made some adjustments over the years to the site. I want to even go as far as to say that if you do click on that field to enter it, they let you know what forms they'll accept the answer. So if your follow-up question is going to be, well, okay, what would that look like mixed? All right, here, watch. That's a big number, right? We're not doing mental math. I don't know. That's good. Somebody put with a calculator 155 divided by 12. 12 point something. 12 point something. So okay, so then we would put. So I know it's gonna go in 12 whole times without going over. I know I have to keep 12. What's 12 times 12? What's 12 times 12? 144. So then what is 155 minus 144? Yes, it is 11. 12 and 11 twelves. Close but no cigar. Okay. All right, fantastic. See how wonderful that was? Somebody took advantage of some resources that were available to you and went over it step by step. Connections were made. I enjoyed that. So let's go back now to our E class. It's the first problem I go over this year. It's an exciting time.
Yeah.
I also like this system because if it ever comes time to speak to a student or a parent for that matter about well, hey, why are we struggling, or why don't you ask questions and stuff? Sometimes they get, oh, it's because I'm shy. It's because I'm shy. So like, if you don't like asking questions in class, yeah, I guess here the system I've used before, which was OneNote, it was anonymous. I guess this one isn't, but at least you don't have to actually verbally ask the question. Are all of these the same? You just posted, or one of them subtraction?
That one's different.
The one here on the bottom? Okay, so let's do that one.
I'm struggling. Stop after this one. I quit.
Why'd you quit?
Because it's too hard.
No. Did you ask for a hint?
No, I didn't want to get it wrong.
Why didn't you do it again? It's better than just sitting there doing nothing.
You could redo it.
Yeah. Again, just to reiterate, you know that you can do these an unlimited amount of times. I'll keep the highest score. So like if you bomb it one time and you get like a 30 on it, but then you do it again and get an 82, you're gonna only keep the 82 on this. Let's say one more thing. I just remembered. And you know that you don't have to do these in order. So like if you are going in order and you get to the fifth one and you're oh wow, I'm so confused, I don't know what to do. Okay, move on to the next one. Go on to the next one. Leave behind the one that you're struggling with. And another thing also, I mean, it looks like the person who posted this just realized it, but and most weeks it's not going to be an issue because there's only going to be one assignment. But please post under the appropriate thread just to make it more organized. So this is the fraction one, should have been posted under the fraction. Okay, so let's do the same steps. Same exact steps. Subtracting, but same steps. Yes, sir.
Wasn't it the ones we had to do the first 13, right?
The only 13. It's the 13 that we're posting. What was the first step we did last time? Two. Yes, ma'am. Convert to an improper fraction. So over 6 minus over 3. But I need a numerator. Are you doing calculator tricks back there? What? Just write it down in your notebook. Feel free. Let's get some numerators. 6 times 9 plus 1 is 55. Ugh. And 5 times 3 plus 1 is 6. Now we need a least common denominator so that I don't have to write everything out. Can we do this mentally? Here it would be 6. If I count by 3s and count by 6, the first number that's in common is going to be 6. But now here's something that we didn't see on the last problem. Because now when we go to adjust the numerators accordingly, this first denominator did not change. No, you just leave it the same. If the, oh, okay. If the denominator did not change, the numerator did not change. Now on the second fraction, though, we multiplied by 2, so there was a 16 there before, now we get a 32. The only other difference between this one and the last one is that now that the denominators match up, instead of adding, we're going to subtract. We're still going to keep the denominator the same. 55 minus 32 is 23. I know that those do not have a common factor, so I should be able to just write 23/6 and get it correctly. If you wanted to go back to mixed, that should be like what, 3 and 5/6. 3 and 5/6. Any questions there? Okay, so that's it then with review. This is the last time we see each other before that assignment is due. When is the week 1 assignment due?
Tuesday.
Yeah. No, fractions are due on Sunday. I gave you a couple extra days just because we didn't have the quiz right away, so I know that the first week I gave you a lot of work, so.
So you changed the due date to the 14th?
No, it's always been there since day 1. That hasn't changed. The fractions are still Sunday. Fractions are still Sunday, but then there's also the week 1 assignment, which is on polynomials, which reminds me, I got held up this morning. I need to change this.
How many links are there for that?
How many links are there for that one? I don't know. I have
5.
How many? 5? Okay.
5 or 6.
Wow. It's getting loud. Yes.
All like the websites posted, that's not all due.
Say that again.
So all the websites that you posted, that's not all due.
Let's go back and look at this again. In the weeks to come, unless there's some exceptions, but for the majority, as far as I can tell you, for the weeks to come, this is not going to be a source of confusion because for any given week, there's just going to be one assignment. But because this is the first week, and I wanted to get you guys started right from the beginning, I gave you 2 assignments. One assignment for operations with fractions, that's due on Sunday. Everything that's within operations with fractions is due Sunday. When you go on the site, on that main page on the dashboard, it tells you when each one is due. So every single one of these 13, are due on Sunday. Okay? But in addition to that, you also have an assignment, which is what I've started lecturing on the last couple of days. And that's just your traditional weekly assignment, which in this case is called week 1. Next week assignment is going to be called week 2. Here you have 6 that you have to do, but those are going to be due Tuesday. They've always been due on Tuesday. So if you're trying to like prioritize and figure out which ones you want to do first, do the fraction ones first, because even though there's more of them, they're due earlier, they're due sooner. Ideally, I would have loved for you guys to have all that done in the first few days, but I know it was confusing. You were still learning, how everything works and stuff. So, but believe it or not, quite a few people are actually either done or very close to being done on those already. So we can get started on the second part. Are we clear on that? Because this is not due until Tuesday, even though it falls under week 1, like next week when it's week 2. If you want to post any questions on this, you can still go do it under the homework part. The fraction one's going to be due already, but this one you can still post. Alright, so let's move on then. Multiplying polynomials. Remember that a monomial that a monomial is also considered to be a type of polynomial. So we will need to know how to multiply monomials times polynomials and then poly times poly. Like multiply one term times a series of terms, which we already know. We covered that, believe it or not. What do you call it when you multiply one term times a series of terms? What do you call it when I multiply one term times several terms? If I get one term, I just keep on multiplying it and multiplying it and multiplying it. Say it again. Distributing, sure. The only thing is that we only did it with either a 1 or a negative 1, but we did it. You know, today you're going to have to do it with other numbers. You're going to do it with variables, which is why we need to learn the rules. And then you're also going to have to learn how to multiply several terms with several terms. That's where this little acronym comes in. If you've heard of FOIL before, have you been taught FOIL?
Yes.
As in any other acronym, those words have a meaning. It's not, we're not talking about like aluminum foil, but I don't really use the meaning of it. Some teachers try to emphasize what the F, the O, the I, and the L mean, but this only really works if you're multiplying strictly binomials. So it's kind of limited. But the reason why I still put it up on the board is for the purposes of reference, so that when you hear me say, hey, what's the next step? And oh, it's foiling, then we know that what we're supposed to be doing is multiplying polynomials. With the exception where now, if it happens to be just one term times several terms, then we'll use the word distribute instead of foil. Okay? Both of these are types of multiplication. Distributing is a type of multiplication. Foiling is a type of multiplication. So we're going to have to follow the rules for multiplying, which are given to you here. When we multiply, where? Give me a location. Where do we multiply? We multiply just constants and coefficients. So if you're comparing and contrasting, think about the adding and subtracting yesterday. Where did we add or subtract? When we were combining like terms, where did we actually add and or subtract? What got added and subtracted? Somebody said it. The coefficients. Same thing that's underlined there. What happened to the variables? Nothing. Yesterday, nothing happened to the variables. X squares got added with x squares, and they stayed as x squares. X's got added with x's, and they stayed as x's. So the adding and subtracting took place in the constants and coefficients. Today in multiplying, the multiplying is going to take place in the coefficients. But oh, here comes the monkey wrench. Yesterday, what happened to the variables? And thus their exponents? Just said it 5 seconds ago. Nothing. What happened to the variables? Nothing. When you're multiplying, what's going to happen to the variables? You have to add the exponents, but only if they match. If the variables match. I think the majority of today's lesson is examples. So that might be a good thing. Here we go. It's a good start. What is the difference between these two expressions? Maurice. All right, go ahead, Maurice.
The first one's being added, the second one is multiplication.
Good. This is addition. Addition falls under the rules of like terms. Are these two terms like? Yes, so they could be added. What is x squared plus x squared?
2x squared.
2x squared. On the right, what are we doing? Multiplying. In algebra, we do not use an x for multiplication. And then the other thing that I looked at here, but how about the dot? Gets used sometimes, but it isn't as common. The most common symbol to represent multiplication in algebra is the parentheses. Okay? So, well, now let's ask the question. Because we got some new rules today. Yes, yesterday you got, in the past 2 days, you got the rules for adding and subtracting. Now we got the rules for multiplying. What does the rules for multiplying say first? You just told me over there we're going to multiply, so let's multiply. Jake, right? Jacob?
You have the experiment.
No, that's the second step. What's the first step say? Maurice?
Multiply any constants or coefficients.
Beautifully read. Yes, multiply any constants or coefficients. So here in this case, they're both variables, so there's no constants, but there are coefficients. What's in front of x squared? A 1. What's in front of x squared? What's 1 times 1? 1. If there was nothing coming afterwards, you would leave the 1. But because there are variables coming afterwards, you do not write a 1 when it's a coefficient. What's the second rule say to do? See, now we have to add the exponents. Since both of these are x's, they have both variables are the same. You would add the exponents. 2 plus 2 is 4. So where does the confusion occur, especially when the children do not study? Is they learn these rules, so they come back over here and they want to say, oh yeah, x squared plus x squared, yeah, that's gonna be 2x to the 4th. And don't confuse the steps. I have a big head. This thing is like 30 minutes. Okay. Any questions there? All right, what's the difference? Yeah, look, one is still addition, one is multiplication. Now, what do they have in common? How about that question?
Same.
I told you, I warned you about this. What word did he use? He used the word equation. What don't you see anywhere on the board?
Equal sign.
No equal sign. Don't use that word yet. We haven't got to equations yet. What do they both have in common? They both have parentheses. When you do any operation, add, subtract, multiply, divide, anytime you do any operation, that falls under the category of what's called simplifying. When we get to your other E word of equations, what do we do to equations? Solve. Equations get solved. Expressions get simplified. So on both of these, we're simplifying. Part of simplifying is removing parentheses. You cannot have an expression be in simplest form if you have a parenthesis. So I have to get rid of both parentheses. But because they're different, the way I do so is going to be, well, believe it or not, it's actually the same, but it's going to look different. Here, how am I going to get rid of this parentheses? I cannot do what's inside. Why can I not do what's inside the first parenthesis on the left?
Not the same variable.
Go ahead, Ruth.
Well,
Jake said it better. Go ahead.
They aren't just.
Just say the same thing you just said.
They're not alike.
They're not like. That's exactly right. They're not like. They are not like terms. So I cannot add. So I'm going to have to distribute. But the question is, the $1 million question is, what do we distribute on this first one here left? What is outside of this parentheses? A 1. It is not a 2x. It is a 1. And anything times 1 is itself. So we get 2x plus x squared plus 3x. Then now this just becomes like yesterday. We go from biggest exponent to least. The only like terms are the 2x and the 3x. X squared just drops as if it was hot. And then 2 plus 3 is 5x. But now on this second example, we're multiplying. What's outside of, I still have to remove the parentheses, but what's outside the parentheses? A 2x. So yeah, I'm not going to just drop everything down. I have to actually know how to multiply. So let's follow the rules. Multiply the coefficients. Here we have a 2. What's in front of x squared? 2 times 1 is 2. The variables match. So what do I have to do with the exponents? Add. 1 plus 2 is. Then we have to do the same thing over again with the 2x and the 3x. 2 times 3 is 6. So I write plus 6. But it's not going to be 6x because they both have an imaginary 1 on top. So 6x squared. 1 plus 1 is 2. X times x is not x. X times x is x squared. Very yes? Okay. Let's keep on going. Let's multiply here. Well, these are just two monomials, pretty basic. What is, let's try to go for, we got 10-minute warning. So what's 4x and 5x?
20x squared.
20. That's 5 times 4 is 20. x squared. Well, ask, if you're lost, ask. How did I get to 20?
Multiply 5 and 4.
5 times 4. How did I get x squared? No, not 2x. X times x. X times x is x squared. This is in algebra when you write a variable next to a number, like when you have a coefficient, that means multiplication. So this is the same thing as saying 4 times x times 5 times x. I was able to multiply the 4 with the 5 and get 20. I was able to multiply the x with the x and get x squared. Let's go to the next one. What is negative 2 times negative 7?
14x7.
Positive 14. What happens? Yep, negative times negative is a positive. 3 plus 4 is 6. But wait, Mr. Romero, I'm so confused. I don't get it. But like, why? What do you mean a 7? I don't get it. Well, think of it this way, right? Remember, in algebra, you're going to multiply these right next to each other. So another way of saying, it's easier if you listen. Another way of saying x to the third is saying x, x, x. Another way of saying x to the fourth is x, 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 x. How many x's do I have? 7. 7x. How we doing back there, Princeton? Okay. Let's continue here. This you can go through fast. This is a monomial times a polynomial, right? So we're going to distribute. What is 2x times x? 2x squared. What is 2x times 4? On the next one, on the bottom, what is negative b times negative b squared? Oh,
B cubed.
Negative times negative is positive, and this would be b cubed. Because 1 plus 2 is 3.
I thought you said cube.
Negative b times negative 8 is? Positive 8b. Any questions there? I'm pretty sure this is a 2-day lesson, so even if I don't get to everything today, let me see. No, I'm not done yet. I still got time. I just want to double check, see how fast I have to go. I just want to double check and make sure. It should be. Come on. Yes, it is. All right. So today's a 2-day lesson. So we'll maintain the pace and keep on going slow. If I don't get to everything, we don't get to everything. Okay. Okay, here we got to distribute here. Why don't we do this? Let's let you guys do these 4. Yeah, go ahead and do those on your paper, and then let's see. The bell rings at 20, right? So I'll give you 2.5 minutes, and then I'm gonna do them all fast. Yes. Your notes. I think this is now more effective if without me guiding you, you attempt to do these 4 on your own. Definitely don't need to pack up yet. Got plenty. We still got about 5 minutes before the bell. So I'm giving you like a bit of a head start. I'm actually we'll lower that to 2 minutes, and then what I'll do is I'll come in behind you and I'll play catch up. I'll write my answers on the board, and then we'll go one by one and see if you have any questions, and then we'll wrap it up there. Yes. Yes, of course. Yes. So I'm actually. Imani brought up a good point. Right? Another very common source of confusion is now you get all obsessed with like terms, and you only want to multiply terms if they're like. But no. Like terms only applies to adding and subtracting. Terms can always be multiplied. Now, whether or not you're going to be able to add exponents because maybe the variables aren't the same, maybe sometimes you only have a 1 in front. to multiply, but you can always try to multiply. Go ahead, Zach. You can do it, buddy. 4 problems. Finish up. I'm giving you a head start. You getting confused? All right, I'm coming in behind you.
What is tax?
Okay, so if you did as you were asked, look at number 1. Look at my board, look at your paper. If something's different, raise your hand and let me know. Yes, Joseph.
Is 16 absolute squared?
Which one?
At the end, negative 16.
All right, I'm on number 1 only.
Oh.
So we're saying number 1. Are there any issues with number 1? I'm doing my best Vanna White impression here. Okay. Let's go to number 2. Any problems with number 2? Anybody not get what I have on number 2 that we can figure out why? And how about number 3? And then Joseph, what did you want to know for number 4? You figured it out. Any questions on number 4?
No.
Mary, how are we feeling? We're feeling good? Okay, so then remind me on Monday that this is where we left off. Remember that when you get here on Monday, you're scanning in.